Okay, the uniform motion problem, okay, chapter 4.6. Okay, the uniform motion problem is related to the speed problem. Okay, speed problem is, usually when we say speed, what is the speed limit of highway? Like, 60 miles per hour, 65 miles per hour. That's what we say, right? So we usually say that the speed is like a 50 miles per hour. Okay, this means miles per hour means 50, miles. This is miles, right? Miles per hour. So the numerator is the distance and denominator is the time. So when we say speed, speed is equal to the distance over time, right? Then what will be the total distance when you go 50 miles per hour for 2 hours? Isn't it 50 times 2, right? 50 times 2 is the total distance. So same thing. So from this, this is speed is equal to distance over time. Then if we multiply both sides by times, then we have the distance, right? So speed I'm going to multiply each side by time. Then we have distance, right? So we have another formula which equation distance. The total distance is the speed times the number of hours. So ST, we will say ST, right? ST like this. So we have two equations. There's one more. Okay, how about the time? The time is, from this equation, divide the equation by the speed. Then we have distance over the speed, right? So using the speed definition, we can derive three different equations like this. Speed is distance over time, because 50 miles per hour, so distance over time. And then definitely the distance is speed times the number of hours. Common sense, right? So total distance you traveled for 2 hours with the 50 miles per hour, then just multiply, right? Multiply. So I think I mentioned this one earlier. So there are three different equations. So using these equations, we can solve questions. So in this case, we will use DST. Distance is speed times time. Okay, example 1. Okay, 2 cars. Before I do this, let me explain one more time. Why don't we write down the DST in triangle? Okay, DST in triangle. DST like this, and then draw a fraction bar like that. So this one shows that you want to find distance, then just multiply this ST, the denominators, write down the denominator. And if we want to find the speed, then the speed is equal to D over T. Okay, D over T. And finally, you want to find time, then time is equal to D over S. Make sense? So you can memorize the three equations like this. Or you can memorize the equation based on the speed. Speed is distance over time, and so on. Okay, example 1. 2 cars traveling. Two cars. The first car is traveling 10 miles faster than the second car. 10 miles faster. Okay, faster than, right? Faster than. So let's say the speed of the second car. We are comparing with this. So let's say the speed of the second car is X. Okay, X miles per hour. X miles per hour. Then the first car is what? 10 miles faster, so X plus 10, right? X plus 10. Okay, let me draw a little diagram. So these two cars start at the same time from the same position and traveling in opposite direction. So let's say they started from here. The first car is traveling west, and then the second car is traveling right. Okay. So the first car, second car. And the speed of the second car is what? The speed of second car is, let's say, x. Okay, let's just say x miles per hour. X miles per hour. Then the speed of the first car is 10 miles per hour faster. So we can write it x plus 10 miles per hour, right? 10 miles per hour. That's the speed. All right, and then in 3 hours. So after 3 hours, so t is 3 hours. So they started at the same time. So they traveled for 3 hours. And then they are 288 miles apart. So the total distance between these two cars is 288 miles. I'm just drawing a diagram based on the information. Can you see this? So I separate it into two parts, the left of the starting point and the right part of the starting point. And each part has different information. Okay, so find the rate of the second car. Okay, the rate of the first car is x. The rate of the second car, wait a minute. Okay, the rate of the second car is x, right? X. So we want to find the speed of the second car. Okay, look at this. So we have three equations. So we have to use one of these three. Let's think about this. The total distance is given. The total distance is 288 miles. And this distance is the distance that the first car traveled plus the distance that the second car traveled, right? So how about, can I write it like this? Total distance between two cars is the distance that the first car traveled, or first car, plus the distance that the second car traveled, right? Okay, then the distance formula. What's the distance formula? The distance is equal to speed times the number of hours, time. Speed times time, right? So let's plug in all this information. The total distance is 288 miles. And the distance the first car traveled is the speed. What's the speed of the first car? X plus 10, right? X plus 10. And then how many hours? For 3 hours. Okay, plus the second car. The speed of the second car is x. How many hours? 3 hours. So using this equation, let's find x. Then x is the speed of the second car. Okay, so that is 288 is equal to distribute the 3x plus 30 plus 3x. And then combine the like terms. So 288 is equal to 6x plus 30. And then minus 30 each side. Then 6x. Okay, let me write minus 30. Minus 30 each side. Then 258 is equal to 6x. And then divide each side by 6. So divide each side by 6. Then x is equal to 258 over 6. So x is equal to 43. So x is speed, so 43 miles per hour. So this is the speed of the second car, right? Speed of the second car. So that's the answer. Then what will be the speed of the first car? Speed of the first car is 10 miles per hour faster than this, so it will be 53 miles per hour, right? Okay. So when you solve these speed questions, always try using one of these three equations. So in this case, the best equation that fits to this problem is dst. Distance is equal to speed times t. Okay, so using this information, let's do the similar question, problem 1. Please pause and read the question and solve it. Okay, this time two trains. Two trains are starting at the same time but different location. They are 306 miles apart. So here is train A, and here is train B. They started at the same time, and then they're traveling towards each other. So this one is going toward to B, and B is going towards A. Right, like this. Towards A, towards B. And the total distance between these two is 306 miles apart. Right? So this guy is going this way, and this guy is going left. So they will meet at certain point, right? Certain point. Okay, anyhow, they are traveling 3 hours each. So A is traveling for T is equal to, wait a minute, no, not yet. Okay, one car. Okay, one traveling at twice the speed of the other. So let's say the speed of the other is x miles per hour. Okay, so let's say A is traveling twice the speed of the second car, the car B. So let's say the speed of car B is x miles per hour. Okay, then the speed of car A, can I write it like this? The speed of car B, the speed of car A. Then this one is twice the speed of car B, so it will be 2x miles per hour. Make sense? Okay, and then they are traveling 3 hours. So the time for A is 3 hours. The time that car B traveled is also 3 hours. Okay. The trains, pass each other. Find the rate of each train. Okay, so after 3 hours, the train passes. So once they pass, that means they traveled 306 miles, right? They traveled 306 miles because A traveled for 3 hours, B traveled for 3 hours, and they pass each other. That means the total distance they traveled is 306 miles. So let me write the formula like this. The total miles, total distance they traveled, total distance both traveled is the sum of the distance of the train A traveled plus the distance that the train B traveled, right? And then the distance formula is what? The distance is equal to speed times time. Okay, so the total distance is 306 miles. And the distance that the train A traveled is, okay, speed times time. The speed of train A is 2x. And then 3 hours, right? Plus the speed of train B is x, and it traveled for 3 hours. Okay, so that's the equation. So from this equation, let's find x. Then x is the speed of train B, right? So we want to find the speed of each train. So rewrite the equation. Then 6x plus 3x. Then 306 is equal to 9x. Then divide each side by 9. That is x. Then finally x is equal to 3, 4, right? 34. So 34 miles per hour. Then 34 miles per hour is the speed of x. So x is the speed of train B, right? Train B. Okay, then the speed of train A is twice faster than the speed of train A. Is twice faster, see here, twice the speed of the other. So that is 2x. So 2 times 34 is 68 miles per hour. Okay. Okay, example 2. A bicycling club rides out into the country at a speed of 60 miles per hour and returns the same distance at 12 miles per hour. So let's say from location A to B, so when you go from A to B, going out, this is going out, right? Going out into the country and returns. So when you go out, the speed is 60 miles per hour, right? And then let's say, the time is, we don't know. The time is, let's say, X hours. We don't know, right? X hours. So when you return, back, when you come back, the speed, okay, come back is this one. From B to A, right? From B to A. Come back. So when you come back, so back, the speed is 12 miles per hour, and the time is, actually, look at this. Okay, how far? How far does the club? Okay, this is not right. Okay, how far does the club ride out into the country? If it travels a total of 7 hours. So we want to find the distance, actually. We want to find the distance. So from A to B. And then the total hours is 7 hours. So going out and come back takes 7 hours. So total time is 7 hours, right? 7 hours. So let's say T hours is the time it takes when you go from A to B. Then what will be the time when you go from B to A, when you come back? What will be the time? That is total minus, this is total, minus x, right? X. Total minus x. So there will be 7 minus x. Can you see this? So the time from A to B is x hours. X hours. So we already used up x hours. So when you come back, the total hour is 7 hours. So the round trip is 7 hours. So when you go away, go out, it took x hours. So when you come back, it will be total minus x. So 7 minus x. Right, 7 minus x hours. Make sense? All right, then the distance. Okay, so from here, this is important. So using the distance formula, distance that's going out, right? Distance going out. The distance formula is s times t, right? S times t. And then here, the distance come back when you return is also speed times t. Okay, this speed is speed A. Speed out, t out. And then this st is this is speed and time for come back, right? Come back. Should I write a different notation? Let's separate it into two pieces. Okay, above and below. Above and below. This is related to out. This is related to back. So actually, the distance is same. So the distance going out should be equal to the distance. Okay. Distance going out should be equal to the distance returning. Right? So this is distance of out is equal to distance come back. So using the formula, distance going out is what? St, right? St. So what's the speed going out? 60 miles per hour. How many hours? X hours. So when you come back, the speed is 12 miles per hour, and the speed is, the total is 7, right? So 7 minus x. So this is the equation. Okay, so let's solve for x. Okay, solve for x. All right, then this is 16x, and 12 times 7 is 84 minus 12x, right? Then let's move minus 12x to the left, so plus 12x. Then 28x is equal to 84. Divide each side by 28. Then x is equal to, is it 3? Yes, 3. So x is 3 hours. Okay, x is the value of what? Okay, x is the time going out, right? So when you go out, this guy traveled, bicycled for 3 hours. 3 hours. So how far does the club ride out into the country? Then what is the distance d? So the distance is st, right? Distance is st. So the distance is, what's the speed of going out? 16 miles, right? 16 miles. So there's 16 miles times how many hours? 3 hours. So that is 48 miles. So this is the distance between two cities. So this one is a little bit complicated because we first found the number of hours they traveled, and then using this number of hours we found the distance. There are 2 steps: find the number of hours, and then using that one find the distance. Okay, let's try problem 2. Okay, this problem 2 is similar to the example. Okay, so here is the location A and location B. So, okay, let's say this part is out when you go out, and the bottom is when you come back, return. So, when you go from left to right, a pilot flew out to a partial land, so B, that is B, and then come back. So it took 7 hours. So let's say the number of hours that going from A to B is X hours. X hours. Then what will be the time come back? When you come back, that will be total minus total hour minus X, right? So that is 7 minus X hours. Okay, the speed. The rate flying out to this location B is, the speed when you go out is 120 miles per hour. And then when you return, the speed is 90 miles per hour. Okay, then how far away was the parcel of land? So that means we are looking for, this means find what? Find the distance, right? Find the distance. Okay, so before we find the distance, we gotta find the number of hours it took from A to B, location from A to B. So let's find X first. So the distance that going out is same as the distance when you return, right? Back. This is similar, exactly the same question. So going out, the distance for going out. So the distance formula is what? The distance formula is speed times number of hours. So we apply this one. So when you go out, the speed is 120. And then how many hours? X hours. So when you come back, the speed is 90 miles per hour. And then how many hours? 7 minus X hours, right? So let's find out X. X is the time it took when you go out. All right, so this is 120x is equal to 270 minus 90x. And then collect the x terms. Move the x terms to the left. Then 210x is equal to 270. Oh, wait a minute. Did I write the question correctly? Wait a minute. Sorry, I'm sorry. This is not right, right? 630. 630. Okay, so divide each side by 210. 630 divided by 210. Then x equals 3 hours. So when you go out, it took 3 hours. So actually the distance is, so using the distance formula, so let's use d out, the distance going out. Actually, distance going out is same as distance going in. So you can use any distance. So the distance going out is the speed going out. The speed going out is 120 miles, right? 120 miles here, 120 miles per hour. How many hours? 3 hours, right? 3 hours. So that is 360 miles. So 360 miles is the distance. So that's the distance of from location A to location B, which is the parcel of the land. So this is the distance, right? Distance. Okay, so these two questions are very similar. And then the hard one is we have to find the number of hours first so that we can find the distance. Okay.